Hi everybody, John here. Tonight, I just got this finished a little while ago and I thought that I would document it right now. This is a zero force motor, and it's got a timing wheel here, and the timing is 90 degrees off, so the motor is running in a neutral zero field. And so an explanation of that is normally the poles on the motor are facing this direction, and on the other side the opposite direction, and you go across the top of the coils. But this motor doesn't work like that. This motor is completely different in that it's riding the flux lines that go around the outside of the coil like this. And so let me show you a drawing, and I don't want you to confuse this type of motor with this type of motor. This is just a plain old pushing motor or a puller. It's not a push-pull motor. This is a push-pull motor because it's pulling on one side and pushing on the other side. And you can see where the reed's mounted. I'm just using one half of the motor to show you the demonstration. You normally would use a bipolar switch, so let's look at the wave and you can see what the difference is here. Let's expand this out a little bit. And bring this up. And in this signal, you see no AC generation at all. This is incapable of generating any power back. So, what does that tell us? That it doesn't have a counter EMF while it's rotating, which means it's just free in that magnetic field. Now there's 4 poles on this magnet. I did this the simple way to prove to you that it could be done with just all north poles. But normally you'd have 2 south poles and 2 north poles, and you'd have one more reed on this side over here and over here, and it would be firing at every 90 degrees across the blotch wall in the magnetic field. So this being a south pole at the top and a north pole at the bottom, and this being a north pole and a south pole. So you can arrange it so that it pulls in to ride the field or pushes out to ride the field. So I don't want, again, to confuse you with this motor or this motor. One is pushing here and one is pulling, but there is no push-pull arrangement in this motor. And you can see, you can tell if you just do the experiments, that if you try to push-pull this motor, these coils would have to be arranged much different. These coils are arranged vertical, and there is no horizontal coil, so you're riding the flux lines that the magnetic field generates. And let me show you what it actually looks like when you draw it out magnetically. Some disagree with me, but I don't care. I happen to know what it does, and I know what the magnetic fields are. So here's what it looks like. And it looks exactly like this. These being your magnets here and here and here, and here. Now I've arranged this so it's all north poles, as you can see from the drawing. This shows you the timing. And normally there'd be a reed here and a reed over here. This magnet would stay there because when the wheel moves 90 degrees, you want it to fire again in the vertical mode. So you're depending on how you wind this coil is where the neutral part of this coil, where these actually make a figure 8 loop. So they come out of one side and go in the center and come back out this side and come back down here. And you're riding these spins. So when you fire this motor, you're firing it at the neutral point, and it's pulling with a south pole down to this one and repelling with a north pole. Actually, it's pulling all the time. If you think about it, it's starting out at the neutral point and moving up to the top of the pole in both conditions. But it's free from any counter EMF because it can't generate anything. It can only pulse the coil. And the circuit's very simple with a reed switch. It's just a 1K resistor and a transistor that triggers it on. And it's got some horrendous spikes, as you can see over here. So let's move this scope probe down and let's see what we can get here. Get a better look at this wave. Sorry about the glare in the screen. It's the lighting in the shop. So you can see that where it switches on. And since there's nothing to counteract the radiant, you're at 10 volts per division here. So if I move this down, get it in line here where you can see it. So we've got about 10, 20, 30, 40, 50, 60 volts. Now, the one thing that I want to warn you about on this type, if you decide that you want to try to build this, is a very simple build, and anybody can experiment with this. Do not put a capacitor across this reed, because if you do, you're gonna arc the contacts because of the base current. It's going to store the charge and arc them, because I've blown about several of them out, getting it to run and trying to get the timing just right on this thing. It's a 90-degree timing. So the timings, I've moved this wheel, the timing wheel, so that when the magnetic field gets to the neutral point, it turns on. And then it pulls it in the opposite directions. And I put the fan on just to slow it down. And so what I wanted to do was kind of share this build with you guys, since everybody's always asked about a zero force motor and how did you do it. Well, this is the simplest version of it. And what I did was these things. All right, I'm sorry. I accidentally hit the button. But anyway, I'm going to back up a little bit here. I was warning you about this reed. If you notice, the reed is at an angle, and the magnets around the wheel are at an angle. They're not straight across from each other. And that's why I made a 14, basically a 14 pole rotor. So I could do all these experiments. I not only could do this horizontal or vertical, I could make this one horizontal or vertical. And it would be very easy to take the easy spin and wind a plastic coil that goes in here for an arc on both sides, and then you'd have a zero force motor, and your reed would be over at 90 degrees, one this way and one this way. So let me show you the magnetic fields, and you might be able to see what kind of a pattern this actually is in the center here. And this is exactly what the fields do. Is you push the north poles together. They want to spring out and make a super north, and they suck away from the normal poles. So the question is it running on this magnet, or is it running on this super north? And from my experience with this motor, it does some really strange things, and it's very fast, and when it's done right, it's very powerful. It's a very high-speed motor. The original zero force motor could easily do 10,000 RPMs with a lot of torque, and that was done with a bipolar switch, and I just didn't feel like doing a bipolar switch here. I just wanted to get it to run to show you that you could 3D print it. And it's information that people has always asked me about. So once again, here's your zero force motor. And it's not your typical motor, because this would be your typical motor. And so once again, it rides these flux lines from the center point up or the center point down. And here's the wave shape again. Let's see if I can get this. I'm at the max on the scope as far as voltage goes. So you can see that. I'll bring this up so you can actually see what it looks like and expand it out. Here, you can get a trace across there. And you see no AC wave in here at all, or any semblance of it, because there is no generation on this motor, except if you capture these spikes. You can utilize these spikes because they're high voltage. And this is running on a lithium battery because I wanted to see how it operated, if it affected the lithium at all. It does seem to. But then I'm not trying to charge it with that spike either. So anyway, that's a zero force motor. And thank you all for just watching, and I hope I helped you with this. Till next time, bye.